Alright, so I'm going to plug in the numbers, and the population percentage would belong to this interval. It'll be 26.4 minus 1.96 times the square root of 26.4 times 73.6 divided by 212, comma, and I got a little sloppy there. Let me just redo this, and I need some room on my board, so well, I'll just erase the top here. So here's my confidence interval. Hope you have all that down. Pi belongs to 26.4 minus 1.96 square root of p parentheses 100. Oops, I'm sorry, I'm putting numbers in now. Start that over. Sorry about that. Square root of 26.4 times 73.6 divided by 212. So 73.6 comes from subtracting 26.4 from 100, comma, 26.4 plus 1.96 times that square root. So I'm not inclined to write all those numbers again under that square root. This is the margin of error. There is a margin of error. So this part is margin of error. And let's calculate that separately. So let me see. Now, calculate that. I do it piecemeal. You can enter things as one big calculation. It's okay if you're good at that. I tend to advise students, do it piece by piece. So here's how I would think about doing it. I'm going to calculate the inside of the square root. 26.4 times 73.6 divided by 212, and I'll hit equal. And that gave me 9.165 something. Now I'm going to take the square root of that, and I get 3.03. So I did this calculation, hit equal. I took its square root, hit equal, multiplied by 1.96, hit equal, and I get 5.9. 5.93 if we want to go an extra decimal place. So pi belongs to 26.4 minus 5.93, and then 26.4 plus 5.93. So our margin of error is almost 6% for the sample size. Almost 6%. That's the margin of error. So if you think about opinion polling that you see in the news media, opinion polls normally give a margin of error as a plus or minus number. It's usually plus or minus 3% or plus or minus 4%. It's because they take bigger samples. This is a smaller sample. Okay, so to finish the calculation, let's see what we get. Pi belongs to, and I need to run my calculator, so 26.4 minus 5.93 is 20.47, and then add those together instead, and we get 32.33. Alright, so there is a 95% probability. There is and apologize, I'm trying to print rather than write cursive in my videos because my cursive is sloppier. So let me print this. There is a 95% probability that between 20.47% and 32.33% of the students at this high school smoke. Alright, so we have estimated the population percentage for the entire high school. It's between 20.47% and 32.33%. Now my handout, let's see what questions I ask. It says, suppose the national average for smokers in high school is 34.2%. Does it appear that students in this particular town smoke less than the national average? And justify your answer. Well, yes, of course. So if the national average is 34.2, you might imagine it this way. On this continuum here, we have 20.47 and 32.33, and the national average is above that, it's 34.2. So, our high school, here's the middle 95%, and the national average is above that interval. It's outside the interval. It's above it. So this high school is under the national average. With at least 95% confidence, we could conclude that this high school has a smaller percentage of smokers than the national average, based upon this estimate of the population percentage. So there you go. There's a population percentage problem. Well, I'm going to go next to the other two problems covered in this book. Involve comparing either two means or two population percentages. So I'll erase the board and we'll do one of those problems.